Hello, here are notes for section 3.5, working our way through transformations. We're going to talk about compositions of transformations. That means combining two transformations together. But I have a few comics for you today. I have actually two comics. Here's Dog Math. So I wanted to show this one to you first. This is what dogs would talk about when they're taking their math class. And it says, first dog says, I have 3 bones, and Mr. Jones takes away 2. How many fingers will he have left? Because he would be awful ticked at him taking his bones away. And then the second one is one that I would give you guys because you've already had Algebra 2. So if you have not had Algebra 2, this may not make sense. But if you've had Algebra 2, this will make sense. I says to pi, be rational. And then pi says, get real. Haha, very funny. Is it funny or not? Probably not hilarious, but still kind of funny. Because i's are irrational i's are imaginary numbers, so they need to get real. And these guys are real numbers, but they're not. They're irrational, so they have to get rational. So sorry, it's kind of funny, but maybe not. Okay, moving on to compositions of transformations. So we're going to talk about combining 2 or more transformations to produce a single transformation. So basically we've been doing a few of these in class where we do 2 things at one time, but now we're going to put them together and make a single rule that we could have used instead of doing the 2 things together. So that's kind of our goal here. Now the first one we're going to talk about is called the glide reflection. Now glide reflection is using a translation and a reflection parallel to the translation vector. So we have a translation and we have a reflection, and it's parallel to the translation vector. So here's really the definition. It says a glide reflection is a transformation in the plane that is the composition of a line reflection, okay, reflecting over a line, and a translation through a line, okay, through the line, the vector line here, parallel to that line of reflection. So the key word there, which I should circle for you, the key word there is parallel. For it to be a glide reflection, the reflection line and the vector lines have to be parallel. So A prime, B prime, C prime is the image of ABC under a glide reflection. That's a composition of a reflection and a translation. So we've reflected it and then we slid it and it came up to here. So this would be the image after a glide reflection. So it says here you can reflect first or translate first. It doesn't matter, as long as the line of reflection and the translation vector are parallel. So if I wanted to slide and then flip, that's okay too. Either way would be fine, or you can flip and slide. Flip and slide or slide and flip. Either way, it don't matter as long as the lines are parallel to each other. So that's called a glide reflection. Let's take a look at a couple of other things. And again, you can pause the video and go back and make sure you get everything copied down. Renaming a composition. It is possible that a composition of transformations may be renamed by only one other transformation. So here's an example. Here's the blue arrows. The blue arrows show true reflections. Okay, 1 over the y-axis followed by 1 over the x-axis. So we reflected it over the y-axis. So basically we took this shape and we flipped it over. You can see that this point right here is 3 units away, and same point on this side is 3 units away. So this would be like A, this would be like A prime. This could be B, this would be like B prime, and it's a reflection. And then we took this reflected triangle and we reflected it over the x-axis. So this point right here was 3 units above, so this one was 3 units below. This one was 3 above, so 3 below. And this one was 8 above, so we had to go 8 below. And that's a reflection. So we reflected over the y-axis, we reflected over the x-axis. But what we're trying to find out is what would have been the single transformation that would have allowed me to go straight from here to here. How could I have gone in there? So let me do this. Let me put the letters here so we can kind of see it. Here's A, We'll call this one B. And we'll call this one C. So this right here then would have to be A prime. This one up here would have to be C prime. This one over here would have to be B prime. Okay, let's put those next to little spots here. Okay, then down here you'd have A double prime. You'd have B double prime. And you'd have C double prime. Okay, so that would be your second one. Now, how could I go straight from A to A double prime? So let's look at what those points are, because that's what we really want. We want to know how could I have gone straight from here to here without doing the two steps. So A was the point 3, 3. So A 3, comma 3. And A double prime is the point -3, -3. So you probably see the rule already. Let's test the rule, because right now we're saying opposite of x, opposite of y. Would that work for B? B, okay, let's write it down as we look at it. B is the point 7, 3. Lower 7 and up 3. And B double prime, if our rule is correct, will be -7, -3. So let's see if it works. -7, -3. It works. -7, -3. So now we know our rule. So we could put xy would then become -x, comma, -y. But what would the actual translation or transformation have been? How could I get from here to here? Is it a translation? Do I slide this triangle down to here? Is it a rotation? Do I rotate it? Is it a reflection? Can I flip it? And I think actually two answers would work here. You could actually rotate it 180. So we could call it a rotation of 180 degrees. That's one possibility. And that's how you put the notation for rotation. Notation for rotation. So that's one possibility. If I were to rotate this triangle, I don't know if I actually can on here. I would love to be able to show you that. Try, just for fun. If I rotated it 180, and I put it like that, you see how you still have -3, -3, -7, -3. So yeah, that would be a rotation. So we could count it as a rotation. So that's one possibility. But it also is a reflection. If I was to draw this line in here, right through the origin, this is the y equals -x. We could also say it's a translation over y equals -x, not y equals x, because y equals x is a positive line that goes up. This has a negative slope, so it's y equals -x would be our translation. So either one actually would take this to here, but we did two reflections, and we got the same thing. But what we're looking for is a rule, and the rule to get from A to A double prime and B to B double prime and C to C double prime is to flip it across this line, which gives you this rule right here. So if I actually wanted to do the same two transformations of a single point here, let's say I made a point up here at, I don't know, let's say it's at 8, 9. Oops. is at 8, comma 9. Okay, so let's say this is my point. My question would be, if I did the same two, if I reflected across the y-axis and reflected across the x-axis, we don't need to draw the whole thing, because now we have a rule that will tell us exactly what to do for these two transformations. When I have these two reflections like this, my rule tells me I just need to take negative x, negative y. So automatically I can say, well, I know it's going to be down here at negative 8, negative 9. And you don't have to even, play around with drawing a bunch of pictures. You know, because of the rule, that you actually have the right answer here. So it'd be negative 8, negative 9. That's a composition of transformations made into one single transformation. Here's a real-life glide reflection. Footprints. You may not know that, but they are a glide reflection. You slide and flip, slide and flip, slide and flip, slide and flip, slide and flip. You can draw in the line of reflection. You could draw in the direction of the vectors. And what do you notice about those two? I notice that the vectors are going the exact same direction as the line. And if they're parallel, and you're gliding and reflecting over a parallel line, it has to be a glide reflection. So that would be glide reflection. It's a real life example. Here's a short video that I wanted you guys to see that will help you understand a little bit more of the glide reflections. And here's the picture that you draw. So use this when you watch the video, and you don't have to do the second example they have on there, just the first example. Just when this picture, when they've got through it's almost like 3 minutes of the video that you're done, and then you'll be done with this picture. So here it is. Let me see if I can get it to come up. Give it a second. Okay, here it comes. There it is. Okay, you're still using the paper that I gave you guys, so go keep the paper, and she's going to do some work right in here. Here's A prime, here's A double prime. That's right. Eight goes to negative 8, 2 to negative 2. Okay, that's an example of a glide reflection. And she used the two, the reflecting and the gliding, to make one single rule. And the rule was just change your x and subtract 8 from y, and that will be what you need to do for this, for all those points. A, B, and C, if you did this rule, would become A double prime, B double prime, C double prime. That was a glide reflection. Okay, let's go to back here. All right, moving on. A couple of things that I want you to see. Let's try a couple here now. Now, this may not be a glide reflection. This is just a composition that we want to find one rule for. So we want to rotate 270 counterclockwise around the origin. And then we want to translate it 13 to the right and 4 down. So let's look at what the rotation would be first. This was what the rotation. Now you don't have to draw the dotted lines. You don't even have to draw this long line. I was showing you something with those, and I'll show you that in a second. But you do want to put your picture, your dots right here at these 4 points, and you want to draw in that rectangle. But to make a 270 counterclockwise rotation, I need to take this picture and rotate it around the origin for 270 degrees. And that's what I did here. So we did this 270 around the origin, and we came up to what we have here. So that was each point. This G became right here, so this would be G prime. Now that you can see, this is a 90-degree angle, but it's really a 270-degree angle the other way. It's a reflex angle of 270. And then H, my H 90-degree angle, which is actually a 270-degree the other way, would be right here, H prime. And then from H we would go to E prime. And from F I would go to F prime. Alright, so if we listed our points in here, E prime is at, let's see, it's at negative 11, 13. And then F prime is at negative 13, 9. Negative 13, 9. Now what did we do on these? Let's see. So look at what happened. You did the y first and then the opposite of x. So y first would be negative 5. Opposite of x would be just a 5. And y first would be negative 3. And x for x, negative opposite of x would be 9. So let's check H prime and make sure it's negative 3, 9. Sorry, writing with the mouse is hard. So negative 3, 9. So negative 3 and 9. Boom, there's H prime. Got it. Okay, so now we want to do a translation. 13 units to the right and 4 down. So that's going to go here. 13 over, 4 down. Okay, so G double prime will be up here. G double prime, and then of course H double prime, oops, and then E double prime, and then F double prime. Okay, so those are, Okay, that one goes there, this one goes here, here, here. Okay, so E double prime. Let's see what that point is. That's going to go over 2 and up 9. 2, 9. Okay, so let's see. How did you get from E to E double? Well, let's just do this rule first. Sorry. This rule is to do your y and then your negative x. So we did y and then we did negative x. Okay, this rule, let's see what we did here. So we translated, so we added 13 and we went down 4. So that's just 13 and 4, and negative 4. That's our translation. Over 13, down 4. So if you add 13, you're going to get 2. If you went down 4, you're going to get 9. If I add 13 here, I'm going to get 0. If I go down 4, I'm going to get 5. So 0, 5 should be a point. 0, 5. Boom, there it is. Right there, 0, 5. And if I go down 13 here, I'm going to get an, if I add 13, sorry, I'm going to get 8. And if I go down 4, I'm going to get 1. So 8, 1, there that is. And then if I go up 13, I'm going to get 10. And 10, I'm going to go down 4, I'm going to get 5. So there's my reflection. Now what happens if I wanted to go straight from E to E double prime? What if I wanted just one rule from X to Y? What would that be? What would that look like? Try to figure it out first and then look and see if you get it right. So we're going to go to point double prime. Let's see what we would go to. What would we do? How would I get from this E to E double prime? Right off the bat. Boom. See what you can do. Did you figure it out yet? Well, you're just basically combining these two. We had a Y and we had a 13. So our first part is just going to be Y plus 13. Oops. I guess it helps if I click in here. Y plus 13. So let's see if that works. You take your Y value, negative 11, and add 13, you get 2. Boom, there it is. Take your Y value, negative 13, and add 13, you get 0. Boom, there it is. Negative 5 becomes 5, and oh wait, your Y value, just take your Y value and add 13. So negative 5 plus 13, you get 8. So if you wanted to go straight from this first one to the last one, you just take your Y value and add 13 to it. And then you take your negative opposite of X and subtract 4 from it. So the opposite of X minus 4. So really all we did was put these two together, the front two coordinates and the back two coordinates. And that gave us our rule for those two reflections right there. When you rotate 270 counterclockwise, CCW, it's the same thing as doing 90 clockwise. Those are the same. So counterclockwise would be 270, clockwise would be 90. Okay, one more example, and then the last part's a little extra credit for you. But let's fill in the points real quick. So we're going to rotate, we're going to reflect it on x equals 2. I think that's supposed to be a small r when you reflect. I'm sorry guys, I messed up. Hold on. Interesting. C edit. Okay, so yeah, I think it's supposed to be a small r. Yes. Okay, so reflecting is a small r. So there's our reflection over the line of x equals 2. That's what's going to happen when you reflect it. And then to translate it, we were going to move it over negative 1 and up 8. And that's going to come out like that. So this picture should go straight to this picture. So this F would go here, then it would go there to double prime. So let's put F double prime. This E is going to stay here and then go over 1 and up. So this is going to be E double prime. And then G double prime is going to reflect way back here, then it's going to come up to here. So here's G double prime. And then of course H double prime is right there. And you can put in the primes also if you want to. I want to show you that we want to get from this one to this one. So what would be our points? Now, I did list these. You can list those if you want to. I'll just do it in pen here. E prime would be the same exact point. So 2, negative 8. And then G prime would be 14 and negative 8. That's G. So 14 and negative 8. And if you look at these 2 points, we can probably make up a rule here. We know negative 8 is going to stay, so y is going to stay. We're going to need the opposite of x and then plus 4. Opposite of x plus 4. So negative x plus 4 more. Opposite of x plus 4. Alright, so if we apply this rule to the last 2 points, we're going to keep the y, so negative 2, and then we're going to take the negative x, which would be 4, subtract 4 would be 0, so 0, negative 2 is, hold on, a negative x would be 4, oh, plus 4 would be 8, 8, negative 2, so 8, negative 2, boom, there it is, we got it, sorry about that. Okay, so opposite of x would be 4, and then add 4, so you get 8 again. And you get negative 14. Alright, so there are your points. But what we're concerned about is the going from the first one to the last one to make it one single rule. We know it's going to be a negative 1 and an 8 here, because that's what the rule for this translation tells us right here. It tells us to go over 1 and up 8. So we're going over 1 and we're going up 8. F double prime is the point 7, 6. And, ooh, that was, my bad. Create an E. 7, 6. E double prime we'll put as the point 1, 0. Okay, let's just use those two. Let's use those two. Let's find one rule that would get us from the first one to the last one. And again, we're just going to put these together. So if we take negative x, and you put a positive 4 together with a negative 1, you're going to get a positive 3. So negative x plus 3 should get us from this point to this point. Let's check it out. Negative x would be a negative 2, plus 3 is a positive 1. Awesome. Check. Opposite of x would be a positive 4. Add 3, you get a 7. Check. So let's apply it here. Negative x would be a 10. Add 3, you'd get 13. Where is G? Oh, there it is. 13. Boom. And then for the y, this y stayed, and then you have to add 8. So it's just y plus 8. So let's see if the y worked. Y, negative 8 plus 8 is 0. Negative 2 plus 8 is 6. Negative 8 plus 8 is 0. Boom. 13, 0. There it is. G double prime. Alright, and the last one, we'll apply negative x plus 3. So the opposite of x would be a 4. Plus 3 would be a 7. And then we're going to take the y value and add 8. So I'm thinking negative 6. So 7, negative 6. Boom, there it is, H double prime. Got it. Okay. So the last slide here is just extra credit. So if you want to cut this off of your notes, here are all your answers. If you could put them on the right lines, look at each one, see what it's asking you to do, see if you can figure out what goes on each line. You get 1 extra credit point for every one that's correct. So you have a possibility of getting 8 extra credit points on this one assignment, or this 1 extra credit here. But it must be turned in tomorrow. So good luck, and we'll see you guys later.